Alright, this is number 39 on the EOC review. It's long enough to have its own video, so I'll make it number 39 have its own video. And so yeah, this trapezoid down here, and it wants to extend DE and CF to make a triangle where that point be. Let's first do it algebraically. So in order to do it algebraically, we need those points for DF. We need to make an equation for line DE and line CF. Line CF is really easy. Line CF doesn't have a slope. The change in x is undefined because it's just up and down. So the points are 0, 1 and 0 for C, and 1 and -2. So the 1 values are the same. The 0 in the bottom of the equation of the change in x and the change in y, because the slope is change in y divided by change in x. Right? So this would be 0. Doesn't matter what this is. Right? So this would be an undefined slope. When the slope is undefined, x equals whatever that x value is. That is the equation of the line CF. Right? X equals, in this case, 1. Okay, that's the equation of this line. Well, that is the equation of that line. Okay, so that's as easy as that one. Okay, we're going to make the DE orange. DE, on the other hand, has a slope. Okay, and D is -1 and 0, and E is -2 and -2. Alright, so we can figure out the slope of this thing. The slope is change in y and change in x. So it's going to be changes in y is +2, change in x is +1. So it's going to be a slope of change in y is 2, change in x is 1, so change is going to be 2. So man, did it again. So you can start drawing your equation by saying that y equals m is 2, x is x, and plus b we don't know yet. Okay, but we know 2 equations that this line falls on, so you can take values from either one of these equations to solve for b. I'm going to take the easy one because this will make the math easy. I'm going to take 0 and plot it in for y. 0 equals, I'm going to take -1 and plot it in for x, -1 and plus b, and I'll solve this for b. That's -2, right? So put that on the other side. B equals 2. Okay? So from here I can take that now and I'll remake my equation. By equals 2x plus 2. That's my y-intercept. Alright, so that's the equation for that line. So I know that where this line and this line meet is where the point is going to be. Right? So where these two lines equal each other is where that point of intersection will be. So I need to set these lines equally to each other somehow by setting these equations equal to each other somehow. And in the past I've set the y values equal to each other, right, and set the y values in terms of x, and I'd solve for x. But here I don't have a y value, I only have an x value. So I need to rearrange this in terms of x and solve for my y value. So in layman's terms, I gotta make x equal y and then just solve for y. Okay, so it looks like this. Okay, so I'm gonna rearrange this and make 2x equals y minus 2. Okay, and then divide both sides by 2x. I'll move this over here. Yeah, I can do this. Okay, I have enough room. All right, so x equals y divided by 2. Wait, is that supposed to be? No, it's not. That's right. Okay. Minus 1. Gotta divide both things in that by 2. All right. So this x will equal that, and x will equal 1, where these 2 points intersect. Well, where these 2 lines intersect, x equals 1, and x equals this term for whatever y is. So I need to set these x values equal to each other. So where x equals 1, my line also equals y divided by 2 minus 1. Okay, because x equals 1 all the way up and down for this line. And this line has this crazy, not really crazy, just a line at y minus 2, or y divided by 2 minus 1. Right, so now I'm just going to solve for this equation for y. I'm going to move this over to here, making it y divided by 2 equals 2. Multiply both sides by 2, y equals 4. So now I have my y coordinate where these 2 lines intercept. With a y coordinate, I can just drop this back into here, into this one, right here. Okay, so I'll drop that back into here. X equals 4 divided by 2 minus 1. I have to drop that from here into here, and that's going to be equal to 2 minus 1 is 1. So if I did everything right, my point will be 1, 4. All right, that's the algebra way. Let's do it the geometry way. All right, so my green line is going to be CF extended. X equals 2, and we're going to extend that up the whole way. X equals 2. That's x equals 2. Extended the whole way. Is that the whole way bright? Yeah, it is. We need to make that more brighter. Put it on both sides of the line there. That's my line. Man, make it bold. That's my line. X equals 2. That's good enough, I guess. It's super thick. Yeah, okay, that's x equals 2. Okay, and then I'm going to make my, I guess I'm making it orange now. And it's going to be D, E. I'm going to extend it, and I've already realized that the slope is 2 changes in y and 1 in x, so 2. Right, so it's going to be up 2 and over 1. Up 2 and over 1. And then that, here's a highlighter, it's orange. That line is going to be right here. I'm not going to extend it the whole way. And you'll see that this point of interception is made right here at x equals 1, y equals 4. Right? So yeah, my algebraing was surprisingly correct. So make that more clear. 1, 4. Right, so that's my math to show it. That wouldn't have fit otherwise. You can pause it and copy it down if you'd like. All right, so if the triangle was rotated at a line of x equals 1. Okay, x equals 1. Well, that's the end of the question. 1, 4. Okay, part B. If the line was rotated at x equals 1, right there, what would it generate? Okay, well, it's going to go rotate this way to here. Right, so this is going to go to here. Right. This is 3, it's going to go through this way, and then it's going to rotate at this point, pivot point here, making this go from here to here. And when it rotates, these things make it look like this turns into like a circle. So that looks like a cone. Okay, this looks like a cone. And remember, the volume for a cone is the base times the height times divided by 3. Right? That's the volume for a cone. Now our base is a circle, right? And the base is pi r squared. The base is the circle, right? And the height is just the height of the cone. So it's going to be, let's railroad track it, our radius squared times our height times pi divided by 3. I'll put pi divided by 3 there to make it shorter. Take up a spot in the denominator. So this is going to be equal to our radius squared. This is 3 squared, right? So it's going to be units matter. So 3 units squared. How tall is it? It goes 2 and then 4 times 6 units times pi divided by 3 is going to be equal to, calculator, 3 squared times 6 times pi equals divided by 3 equals 56.5 units cubed. That's how you do that one. If they're like, keep it in the form of pi, you just don't multiply stuff by pi. You just put pi in your answer. So it would be like 3 squared times 6 equals divided by 3, and it would be 18 pi units cubed. So a little cleaner answer, but either way. So that's the answer to that. Okay, so so volume equals, and I'll put that in parentheses to kind of clean all that up. All right. So if the trapezoid was rotated at x equals 1, or x, if the trapezoid was rotated at x equals 1, okay, so if the trapezoid was rotated at x equals 1, so the trapezoid rotated at x equals 1. When's this thing beep? Oh, you're going to lunch, right? Yep, you go to lunch here pretty soon. This is wrong.